find the probability that there is at least one signal failure on each of the next 3 days. So let's just picture at least one signal failure. That's pretty much telling us that it's going to be greater or equal to 1. Simple as that. Because we're trying to calculate for the next 3 days, we need to pretty much accumulate. So we're going to do this probability times the same instance for every single time. So each probability must be greater and equal than 1. Okay, so whatever you do, don't times it by 3. We've got 3 different products. So this one is a joint one, okay? And yeah, that's really it. Since we have to now resolve this, the distribution is the same. We still got lambda equals a quarter because this is for each day. So each day is going to be the same lambda. And one way to solve this quickly, instead of going from 1 to infinity, we could just reverse this. So if we got 1 and more, we can do 1 minus 0 and less. In other words, just 0. So 1 minus probability x less than equals 0. We have that ready. This is the same as x equals 0 because Poissons are discrete distributions, so they only count single points, integer points like 0, 1, 2. So if x equals 0, we have it over here from the previous problem, which is 0.779. Plug it in, so 1 minus this to power 3 will give us the result we need, which is about 1%. So that's actually 1% chance of happening in the next 3 days head on. Yeah, and let's go to part C.